Hey everyone, let's continue with the directions write as a single fraction and simplify. So this is a subtraction problem. I have a pair again, so we're going to do the subtraction problem, and then with those same two expressions, we're going to do a division problem just to compare. For a subtraction problem, adding and subtracting requires like terms, so I'm going to need a common denominator. So the question is, what can I multiply one or both of these by to make the denominators the same? And this is definitely tricky, so no question there. But I want to remind you that you can look at this first one. Oh, man, did my thing turn off again? No, it didn't. As this first denominator, our exponent rules say that's exactly the same as e to the 2x times e to the 1. And e to the 2x I can even go further with. I can say that's e to the x squared times e to the 1. So there's other ways to look at it, but I think this matches up the best with the way we look at our other fractions. So you can actually factor that first one out, which means the second one really just needs to be multiplied by an e to the x times e to the 1. Right? We already have one of the e to the x's that's in the first one, but we don't have the other e to the x or the lonely e. So we're going to get 2 over e to the 2x plus 1 minus, okay, so we go e to the x plus 1, right? Add exponents, e to the x plus 1 is e to the 2x plus 1, and then on the top I have 3e to the x plus 1. Really, you could leave it e to the x times e. I wouldn't be hugely upset by that, but I think it looks better when I put it back together. So looking nice is part of the thought process. Okay, so when I do my subtraction, that just means I subtract the numerators, and they're not like terms, so I can't really do anything other than write the fact that I should subtract them. And that is my final answer. So really scary looking. So I think the simpler thing that you're supposed to spot in that one is that you're subtracting fractions. So you just need a common denominator. And 2 is that e to the 2x plus 1 can actually be written as factors that can actually be split up. Okay, let's contrast with what happens when you do that, only it's a division problem. So for division, I think our big mantra is multiply by the reciprocal. So we will have e to the x over 3, and then multiply straight across. So I think we have a couple of themes for multiplication. One is with fractions, straight across the top, straight across the bottom. The other is if there's much in the way of addition, subtraction in the mix, we need to distribute. Maybe the third would be that if you're multiplying things with powers, you add the powers to multiply, and we actually can use the other version of that, which is if you're dividing things with powers, you can subtract to combine them. So I am actually going to combine the e to the x's. I'm going to say, okay, this is the same as e to the x minus 2x minus 1, and it should be a minus 1. You're subtracting the entire 2x plus 1, which means they both become negative, which is 2e to the negative x minus 1 over 3. And I actually think that's a really interesting one because that does look like a negative exponent. So you could push it to the bottom. Equals, there we go, 2 over 3e. If you move it to the bottom, it changes the sign, which would make it x plus 1. It doesn't just change the sign in front of the x. You could factor that out, might help it make sense as well. But I think there's room to argue as well that we don't know whether x is a positive number or a negative number. So for example, if x is negative 5, then back in this expression right here, we get negative, so opposite of 5 is 5 minus 1. It's actually a positive power. So with the variables in the mix, it's a little trickier to say whether it's positive or negative unless I specify. But I think I do kind of like the second version of that better. Okay, so there it is with some weird looking exponential pieces. And remember, e, you might be thinking about that as a variable in these, but e is just a number in math. It's approximately 2.7. So I just want you to be used to seeing it and just be aware that it's a number, and I'll be happy for this class. Thanks for watching.